quick recap about our setup. I'm using DigitalOcean. On this I have created two nodes. One I call this master node, other is the worker node, both having similar configuration. 2 cores CPU, 2 gigs of RAM, 60 gigs of disk space. Same here. And the OS is Ubuntu 22.1.0. Same here. And the components: kubelet, kubectl, kubeadm. Runtime is containerd. And same here. Difference is that here we are going to use kubeadm init command, and here it will be kubeadm join command. So this is what we have discussed, and during the installation we saw some issues, so we'll address that. We have to disable swap and load some kernel modules and some network configurations. Yeah, so that is at a high level. So let's continue the installation. Get the droplets. Any region we can select. If you select closer region, then it will be faster. These are some advanced SSDs. I'll take the basic one, I mean the regular SSD. So this is the starting price, $18, 2 GB, 2 CPUs. Select password based authentication. This Ubuntu master. Meanwhile, let's create worker also. Name this worker. 1.26 is the version. So let's connect to the master node first. New session with the IP. Let me increase the font. Here you need to select the connection. You can select here like 10 seconds to keep your session active. Okay. Similarly, let's connect to worker node. We copy the worker IP here. Worker IP. We give that password. Let's increase the font. Click on connection. Can give like 10 or 15 seconds. Okay, so we are connected to master and worker nodes. So I'll execute all the commands that we have discussed from here. Okay, apt get update to update the packages for Ubuntu. So we'll start off by installing the runtime containerd. Apt install containerd. Same on the worker node. And what's next? Runtime also has CNI plugins, so we have to download that. We download here also and extract this. First create a directory and extract to that directory. Okay. So this step was missing last time when we installed. We have to create a config for containerd. Let's create this directory. The config is expected in that directory. So if you execute this containerd config command, it will show you the configuration. It will print you this configuration, which we have to copy in that location. So this command is going to do that. It's going to copy in that /etc containerd in a config.toml file. Same on the master node also. And once you do that, it's better you verify if that file is copied there or not. Yes, we have that file. Let's check here. Yeah, the file is created. In this file there is a system C group. Okay, we have to enable that. There is a variable called systemd C group. This has to be enabled to true. So let's open that file. Search for, this is case sensitive, so search like this, uppercase S, systemd C group, true. And this is a configuration of the run C. Same on master, systemd C group, true. Now our containerd is ready, containerd configuration is ready. We'll move on to the next step. Yeah, we have to restart containerd to load those worker. Now coming to the swap, net filter and kernel modules. So we'll start off by disabling the swap of the places. So this will disable swap during the startup. We copy this from here. Swap is disabled. Let's open this file. Copy this. Same on worker. And finally the network configuration. This will forward the network packets to the IP tables, IPv4 and IPv6. Where did I execute this? Conf. It's not here. Let's reload the configuration using sysctl. So we have done with all the prerequisite kind of things like installing the container runtime and updating the network configuration, loading the kernel modules and disabling the swap. Now comes the actual installation of kubeadm. Let's update the packages, places. I think we can do this in a single go. Just copy that. Okay. Okay. Anyway, doesn't matter. And in the end you can see that we are holding these packages so that during the distribution upgrades these packages are not disturbed. We can check the kubeadm version now, 1.26. It's better to check on both sides. Make sure that we have downloaded the same version on both places. Okay, now let's initialize the cluster using kubeadm init. This has to be done on master node. Okay, kubeadm init pod network seeder. You can give this 192.168.0.0.16 for the IP ranges of the pods. Let's execute that. So in the background it's going to create some certificates and install the control plane components like the API server, etcd, core DNS, scheduler, control manager, those things. Once the initialization is complete, we'll get one token and we can use that token and execute on the worker node. Also, the config generated to connect to the cluster is created during kubeadm init. From the logs you can see that it says that you need to create a directory called .kube in your home and you have to copy admin.conf to that location. Okay, so let's do that first. Okay, since I'm already on root. Okay, let me create this directory first and then copy this admin.conf to .kube config. There is another way. One way is to do this, you have to copy the config. The second approach is you can export this file. This is a standard location of your kubeconfig. You can export this to a variable called kubeconfig. Even then you can access your cluster. Let's try kubectl get node. We can see that single node as a master. The status is not ready because we have not installed CNI for this cluster. Okay, let's take this token. I missed this, I guess. Okay. Now let's see kubectl get nodes. Yes, we can see two nodes still in not ready status because we haven't installed CNI plugins. Let's go ahead and do that. Copy this. You can get this from the Calico website. I'm installing Calico. You can install Flannel or ViewNet. Anything is fine. So you can see pods are created for Calico, which is in Calico namespace, Calico system namespace. I think pods are up. Let's check the pods. Sorry, I need to check pods in Calico namespace. Okay. Now let's check the status of the node. You can see the pods are ready. Right, pods are ready. We can try to deploy some application. Right. Let me deploy Nginx app. Create deploy web app is equal to Nginx. Okay. Let's see if this got deployed. Okay. So there you go. Our application is up and running. The cluster is ready. Okay. So here's how you can create a single node cluster. You do kubectl get nodes, pass this flag, show labels, and you can filter for this label called node role control plane. Yeah, so that is the label. Okay, so you can find that label there and you can run this command kubectl taint node, give the node name ubuntu-master, paste this and give minus here. Okay, it's untainted, meaning that you can now schedule your workload on the master node also. Okay, now suppose I scale this application, scale deploy web app -- replicas equal to say 5. See the pods now, they got scaled. Let's see where the pods are going. You can see here that few pods are going on master node, right? Because we have removed the taint, that's why the nodes are now scheduling on master also. If the taint existed, then it will only go to the worker node, which is the default behavior. So if you want to create a single node cluster, create a VM, initialize that using kubeadm, that will become the master. Remove this taint, that will also become the worker. It acts as a master and worker as well. So these are the pods. Let's check the containers. So we have installed containerd. With containerd comes a command line also called crictl. Can type crictl. Okay, that is your CLI. Using this CLI, you can check your containers. crictl images. You can see the images. Okay, from that there should be Nginx also. Yeah, this is Nginx. How do you pull the images? crictl images pull docker.io/library/busybox latest, then just pull. Okay, crictl images. Okay, so there you got the image. Let's check the running containers. crictl ps-a, same like docker. We can see the running containers. Here we are seeing pod for the Nginx web app that is running as a container. You can see here, which is the web app. If you want to clean up the cluster, you can use kubeadm reset. Okay, this will clean the cluster. Cleaning means it will remove the configurations from etcd Kubernetes. Okay, and it's going to kill all the pods that got created. I mean, basically it's a reversal of kubeadm in it, we can say. But the config file we have to delete manually. Okay, the config file that we copied, we have to delete that manually. Okay, here it's not there, but those are the steps. Okay, kubeadm reset and delete the config.